Alrighty, folks. Day 4. We are on chapter 6, and then chapter 7, which is confidence intervals. We've got this little bit right here, and we're going to talk about z-scores and all the things. I said for this data, let's just do the 14 students that you guys are, and do the average age of you guys. So the average age for students in your class is how many years with the standard deviation of how many years? So I need somebody.
Can you nicely say that?
To go through, and we are not going to do me because 34 is going to bring the average way up. I'm like double your
Okay.
age now.
Can you
This
say
is
it?
so nuts. Yes, I will.
Okay.
18.9534.
954.
34.
Okay.
18.0329. 18.1781. 18.5014. 18.5890. 18.8575. 18.0712. 18.5945.
18 point what?
5945. 18.5233.
Yeah.
19.0247. 0247. 17.9973. 18.0876. 18.1726. And 18.6466. All right, Reese got an answer.
How many decimal places?
Ellie got an answer. Let's go 4, sure. Why not?
Okay. 18.4450.
Is that what you got too? She's still working on it. Okay, what'd you get? 4450.
4450.
Yep.
Yeah, okay. Standard deviation?
0.355.
3553.
3553. Let's go 0.3553. Holy moly, that's a lot of decimal numbers. All right. What is the z-score for your age? If you are older than 18.44 years, you're going to be a positive z-score. If you're below that, you're going to be a negative. Like Ethan will probably be the most negative. All right, do you remember how to find z-score? It's right here. X, this is you, minus the average, divided by the standard deviation, which is whatever that number is. Okay, calculate him real quick.
Okay, what is it?
U minus the average divided by the standard deviation. Okay, so look you up on the chart. Subtract the 18.4450 divided by 0.3553. You should get a number between -3 and +3. Like you should, ish.
Negative point.
Divided by 0.33.
Divided by 0.3553. Yep.
X minus X.
So like me, I'm like 34.5
How many decimal
something
places? 1,
minus
2?
18, 2 decimal places
2, that's it.
on a z-score because the chart that you look it up only allows for 2 decimal places. So this is me. That's what I look like, which is going to be way big. I'm like way many standard deviations. But my data wasn't taken into consideration in the average. Otherwise, it would be like way different. So z-score. Z-score. All right, now 33. Oh, wait, did we fill the bell curve out?
No, we need
Do we need to fill the bell curve out? Yeah, let's do it. Okay, 18.4450. All right. If you add 0.3553, oh, Lord, I don't know.
18.8003.
8003. Okay. If you add again, 19 point something.
19.1556.
Okay. And 19 point
5 something.
What would we divide it by?
6 something, I think.
The standard deviation?
Yes.
5109.
5109. Okay. All right. Subtract.
18.1 something, right?
I don't know.
18.0897.
Okay. 0897.
17 point something.
17.734.
7344.
Yeah.
Okay. and 17 point something.
3791.
3791. Thank you. So, Ethan, what are you?
Can we write the percentages?
Wait, what was the farthest one for me?
No, what is your age?
Furthest right?
17.9973.
Furthest right?
So 17.9973. So you are here. So you are about negative 1 point something. 26. That's what Ethan is. Negative 1.26. Okay. Who are my 19-year-olds?
Brian.
Brian, you are 19 point.
19.0247.
So you are right here. So you are right under probably 2, like negative 1.8 or something. I don't know. What'd you get? What? Positive 1. Blech. What'd you get for your Z-score?
1.63.
6.3? Okay. All right.
Each one of those
Because that's
ticks
how much
one,
he is
right?
over. Yep. Each one of those ticks is 1. So this is where 0 lives. This is where 1 lives. This is where 2 lives. This is where 3 lives. Negative 1, negative 2, negative 3. Okay? That's what those are. Got it? Okay? All right. So you will be different. All right. Now, number 33 and 34. What percent of students are younger than you? So I'll just go off of Ethan's because, like whatever. Less than 50% of students are going to be younger than Ethan. How do I find out what percent that is?
On the chart, right?
You look at it on the chart. So on Ethan's chart, okay, this is not on yours, but on Ethan's chart, I'm going to go to the negative side and look up negative 1.26. It should tell me how many people are younger than him. Ethan, how many people are younger than you? Or what percent? If you look it up on the negative chart. Negative chart.
1.2.
10.38% is what's younger than Ethan. So that is his answer, not your answer, but his answer. 10.38%. What percent of students are older than you, Ethan? You can subtract that. So like 89.62. I don't know. Yeah, something like that. 89.62%. Yeah. Does that work? Okay, now, everybody's answer should be the same for number 35. What percent of students are younger than 18.5? How do you figure that out? You got to find the Z-score first. So, Z-score for 18.5 is 18.5 minus the 18.4450, which is awful close. Like, it's going to be real small. 0.15?
Wake up.
That's the Z-score. Then how many people are younger than 0.15? If you convert that and you look it up on the chart, it is what?
Yeah, that's what I got.
5596.
55.96%. Perfect.
Sure,
Okay.
I haven't got that.
What percent of students are older than 19? So we got to do 19 now instead. But when they ask for older, after we find the Z-score, we're going to have to, or after we look it up on the chart, we're going to have to subtract it. All right. Who are my people? Do you need a chart?
I need.
Some charts.
I need one. Eli,
Let's see what I got.
Eli needs one. What percent are younger?
1.5, right?
Yeah, 1.56.
Yeah.
1.56 is the Z-score?
Yep.
Okay.
It's 94, but I have to minus it, right?
94%.
0.6. So it's 5.94%, I think.
94.06. Come on.
Bigger. Here's a
But then you have to subtract it from 100. Right?
5.94.
That's what I got.
Here's the T in the chi-square. It's just not
Wouldn't it just be the same thing as what we used for Brian, the 1.63?
No, because he's not exactly 19.
What'd you get for a Z-score?
Oh.
Yeah, he's a little 1.56. And when you look that up, it is 99 point something.
96.04.
96.04.
06.
06. But that is younger, right? So it would be
94.
94.06.
The answer is
94.06.
5.94.
94.06. And so then when you subtract it from 100, because we want older, right? So 5.94%.
Yeah.
Yep, that's the final answer. Okay.
Hang on.
All right. All right.
1.56 was your Z-score, right?
Mhm.
Wait, what?
What?
Why'd you guys say
Like Teacher Appreciation Week is next week or something like that. I don't know.
100
Okay.
minus-
All right, let's do between 18 and 19, and then I'll have you do the other one by yourself. So between 18 and 19, 18 point, what's the middle? 4450.
No, we already did these two.
Between 18 and 19,
Well, we did 19.
we want to know what percent, right? Okay, we've already done 19. I know that 94.06% lives below 19. Figure out what 18 is exactly, and then you subtract those two percentages, right? Okay, so if I do 18 exactly, 18 minus 18.4450
Number, right?
is a negative something,
Negative 1.25.
negative 1.25. If you look him up, what percent is lower than negative 1.25? 10.56%. Okay, so what percent of students should live between be between 18 and 19 years old? 83.5%. Perfect. Okay, now between 17 and 18 years old, we already have the 18. You just have to find the 17.
Can you give us a second?
Yep, I will.
Negative 4.2. Where's the score for that? If you want it.
Oh, for 17.
Ooh, so it's just zero.
94.06.
Right?
So it's 0.01%.
0.0001.
0.01% there. But 0.01%.
But that's not what they.
Did you get 83.5? Yeah.
So then
Wouldn't
it's
it
10
just be
point.
whatever Ethan
So what is it? 10 point.
So 17.
10.55 then, right?
17 has a z-score of like negative 4 point something, right? What percent is below him? What percent is below him?
0.01.
0.01%. So what's between those two?
10.6. 10.55.
We're going between 18 and 17. So 10.55, right? 10.56 minus 0.01% is 10.55. We're going between 18 and 19. I know that this many percent is below 18 and that many percent is below 17. Okay? All right, how old is a student who has a z-score of 2.25? You know how to do this.
You do it backwards.
You do it backwards. 2.25 is here. And x minus 18.4450.
No, you're subtracting 0.001. Right, we say zeros.
So you're trying to solve for x. And when you try to solve for x, we got to multiply this guy over and add the 18.4450. Do that the same way for 39, 40, 41.
Minus 0.1231.
You're doing
Hey, number 40, you don't even have to calculate. We already know it.
Oh, I need it
How?
as a decimal. I get it.
A z-score of negative 3.
17.
It's on the bell curve. 17.379, right?
Did you
91.
19.24?
Yep. I sure
Okay.
did.
How about that? Do we know
Hold
what
on,
we're
give
doing?
us-
Are we confused?
Wait, which one are we on?
So you're solving for x. So after you set this guy up, you multiply this guy over and add this.
17.38.
Yeah.
379.
Well, it rounds.
It's all under 3791.
Is this all making sense? We remember how to do this, kind of, ish, maybe? Okay. And that should make sense on your bell curve. Those dates, those
You get
numbers should live where
19.2.
they're supposed to.
Yeah.
4.
Okay.
So 0.850 and then we look on the z-score, right?
0.8500. Yep. Okay, 42. Are we ready for 42? 43 is the same, but 42 is 85% versus 43 is 70 or 30%. Okay? If you are in the 85th percentile, where do you live on the bell curve? You are in the 85th percentile. You live all the way over here, right? 85% of people are lower than you. 85% as a decimal is 0.8500, right? What is that guy's z-score? If 85% are lower than you. This is where we find the closest, and you look it up backwards on the table. Backward.
1.04.
Yeah.
Okay, 1.04 is what you get. So, in other words, now we're looking for who has a z-score of a 1.04. Now you do it the same way as you did the previous three. So you multiply the 0.3553 and add the 18.44. It should be something like right over.
18.81.
Sure. Yeah. Okay.
So now we need to do 30 again. So we need to find 0.30.
So now we need to do 30%. If you are in the 30th percentile, you are on the bottom, right? So you're looking up.
Negative side or positive?
You're on the negative side now. You're looking at 0.3000, right? 30% is 3000. What is his z-score?
Can you start from the beginning?
Negative 0.52. Okay. So find out what x is for negative 0.52.
Okay, so how do we get from the 85th percentile to 1.04?
Okay. So 85th percentile means
We look for
85% are
85%.
lower for you, lower than you. Yep. So you're looking for whatever's closest here to the 85th, and you're not on the positive side.
Negative
85%.
5.2.
Yeah, did you get 18.23, Reese? 500, whatever it's supposed to be.
0.2.
Right here.
Yeah.
8508. So that would be, hold on. We don't care about 8508. We care about the 1.0.
Yeah.
Comey, you are so mean.
1.04 is X.
Yeah.
18.44.
Comey. Help. 44.
They're like, you're.
Okay. Find the date. So do it just like you did the previous ones for the 75th percentile. Find me my date.
Is it gonna be an exact one?
No.
0.75 what?
The 75th percentile. So what's the z-score for 75%?
0.78. Oh.
0.67?
What? Oh yeah. No, I got.
0.67.
Hold on,
Yeah,
hold
because
on.
that's 14.
Hold on.
That's wrong, that's wrong.
One more time. Mr.
No, it's not.
That's right.
What was it?
You're right. You're right.
7, yeah.
What?
6.
What was what?
Don't say it. Don't say it. Don't say it.
What decimal? What was it?
I don't know. 0.67? I don't get it.
Okay, now what do we do?
What is
Yeah,
that?
I'm confused.
0.67. I don't get it. Okay, whatever. Okay,
So
whatever.
18.68.
6.7.
68305. I'm just gonna hold that one.
Okay, now what do we do?
Okay, what do we got? 18 point?
We get the 6.7 from.
Because if you look at 0.7500 on the chart, the closest is 0.67.
That's your number.
Okay, 18 point, give me it.
68301.
68301.
5-1.
Let's just go 30.
5-1.
Just do the 5-1.
5-1.
We're really accurate.
Okay, so that is 18, and they want years, and then months, and then days, right? So we know that that's 18 years. Now what?
Is it the 6 months?
Point 683051. We want in terms of months.
So June.
So I'm going to take him times 12. Okay? I'm going to take him times 12.
224 months.
No, wrong.
Wait, how'd you
Point.
get that?
Point. Take the 18 off. Take the 18 off.
Oh, it's this thing.
8.196612.
8.19662.
661.
Okay, what does that mean?
Wait. So 8 months?
The 8th month. What is the 8th month?
January, February, March, April, May, June, July.
August. Okay? So 18 years, August, and now we take the .1966.
Did you just want
Two.
8 months?
What?
Why would you put August?
Okay, you can put the 8th month. 18 years, 8 months.
What do I take it times?
And
What do I take it times?
we want the day. How many
30?
days are there in August?
Oh,
31.
31. So .19662 times 31.
6 point. That's the 6th.
The 6th day.
And then what about the hours?
You could do hours and minutes and seconds if you want.
So their birthday is August 6, 2006.
August 6th.
No, that's not how that works. Right?
75th.
No, is that?
That's how old they are.
August 6th.
Find the age of a student in years, months who is in the 75th
I don't know if that looks like that.
percentile.
Does that mean that that's the
So if you are in the 75th percentile, you are 18 years, 8 months, and 6 days old on graduation.
Okay, I was.
Oh.
Yeah.
Okay.
Yeah.
I was a little. I
So
was just.
doesn't have anything to do with August. You are 18 years, 8 months, and 6 days old on graduation day. If you are in the 75th percentile. Okay?
Nasty.
How
Hang
about
on,
that?
hang on.
How about that?
Hold on, can we do number 43?
We
We
did
just
number 43.
did that.
Years.
So
What'd you get?
1826.
1826.
30% are lower than you. If you look that up backwards in the chart,
On the negative or positive?
negative, because you're on the left side of 0.
I'm just gonna end it that
I don't mind this page's statistics.
Negative 0.52, right? Is closest to 30%. Yeah?
Yeah.
Negative 0.52. Okay. All right. I want to know what x is, though. So negative 0.52 equals x minus 18.4450 over 0.3553, right? Do all the
Oh,
things.
that's fine.
How did you get the 8 months and the 6 days?
Oh, good question. So this was the number that we got, right?
Yes.
Okay. We took out the 18. Separate the 18 off. You take the decimal that's left over times 12 months, because there's 12 months in a year. Okay?
I think that's good for today.
We got to do one more page. Otherwise, we're going to be, yeah, we got 3 pages tomorrow then. On a Friday. You're not going to want to do that.
Well, we might have to take out
I don't. That's not how this works.
8 months.
What are we doing on Monday? Nothing, right?
Okay, and then what?
Checking and stuff. And we're recording that video.
And then what, Comey?
What?
Then do we take the
The 0.19,
0.196?
and we took that times 31 because the 8th month has 31 days in it.
Takes what?
It'd be really nice if you already took mine.
Okay. All right. We ready for the backside?
Carter just wiped
Yeah, let's get going. So we don't.
Okay. We're not going to do variance, so you can cross them off if you want to, of the table. But here is confidence intervals. Okay. So confidence interval for proportion. What value? What symbol do we use for proportion?
P.
P is for population. P hat is for sample. Right.
Yes, can I help you?
Okay. Mean. What do we use for mean? Mu or X bar. That's population sample. Okay. Standard deviation we use sigma or S. Those are the variables that we use. Okay. For the first two, for proportions and means, we calculate an error. Right? Here we use the Z chart. For mean, we use the T chart only because
We only have 15.
we only have 15. So, technically you use the Z chart, so this should say or Z, but we're not going to use the Z chart because we only have 15 people, so we're going to use the T chart specifically for mean, right? Okay. And then standard deviation does not calculate error. This is where we have to actually plug the two things in, right? To the square root formula. Got it? Okay.
Hang on, don't move.
Okay.
I really don't want to do this.
Well, just
Here, I'm going to leave that there and we'll start calculating. Proportion of students that are older than 18.5. How many students in the class? Are we going to go out of 15 or are we going to go out of 14?
15. Well, does it matter now?
14.
Probably wouldn't matter. Right?
I don't think it really matters.
14.
No, it doesn't really matter. What?
I've already-
So we can go to 15. Let's go. Of the 15 students. Well, I'm a student, sure. Sorry. 15 students, whatever. Okay. How many are older than 18.5? Look on your list. Older than 18.5.
2, 3, 4, 5, 6.
Well, can't we just raise our hand for older than 18.5?
7.
I'm sure, but there's,
8.
I guess I'll raise my hand.
If you count Comey.
8, including me. So 8 out of 15 are older than 18.5. All right. 8 out of 15 is what percent?
A little bit.
0.53.
Yeah.
Okay. Which means that Q hat is
Something 7.
0.47. Q hat. P hat is 0.53. Q hat is 0.47. Okay. So we want to calculate the error for that. Okay. So to calculate the error, we need Z times the square root of P hat Q hat over N. Right?
What are we doing right now? Are we doing proportion?
Confidence interval for proportion. So Z, what do we look up for Z?
95%?
We want 95% for Z. Go down to the bottom corner on your Z chart, and 95% is 1.96. Is that true?
Yes.
Perfect. So 1.96 goes here. Okay, P hat is 0.53. Q hat is 0.46.
Error is 0.129.
And N is 15. And your error is 0.129.
Oh wait, I didn't find Z. Never
Whoop,
mind.
whoop, whoop, whoop,
That's
whoop.
just the inside bit.
Okay.
Take that times 1.96. It's 0.253.
0.253. Holy
That's not what I got, but I don't know.
moly.
You get .044.
I got 0.25.
0.25, yeah.
0.253. What we got for an error?
Yep.
That is
Okay.
Huge.
It's because you wrote 46 and it's supposed to be 47.
Oh, sorry, 0.47. Blech. I lie. 0.47. I don't know if it matters, but okay.
So we're
Well,
giving
it's-
25% off, is that what you're saying?
Yeah. 25% is a huge error.
Holy cow.
Okay, well, what do we add and subtract him from to find our confidence interval? P hat, okay? P hat was 53%, and I am subtracting 25% and 53% plus 25%.
The top one is 0.783.
Okay, so 78% and
0.277.
Yeah, 0.277.
28%, we'll say. Right? So, the number of students that are older than 18 and a half years old should be somewhere between 28% and 78%. And if I gave you that, you'd be like, well, that really narrows it down. Right? Like, that's a huge window. Woo! There's two things that I can do to make that window smaller.
Lower your confidence interval.
Lower your confidence
More
or
students.
survey more people. Those are the two things, right? Okay, whatever. But explain what the confidence interval means in your own words. We are
95% sure.
95% confident that if we survey who?
Seniors.
All seniors.
Wait, we include you.
All stats.
Yeah, whatever, yeah. Yeah, I think we're supposed to just be going off of Blue Hill seniors, but whatever. Anyway, all BH seniors, whatever. Because that's, according to up here, our population is Blue Hill seniors. So all Blue Hill seniors between 28 and 78% will be what?
Older than 9.
Older than
18 point.
18 and a half. Okay?
On grad day.
See, this is where we need to do 14 now. Shoot. Because the average age is going to be like, whatever. Let's go down. Should we go down to 14 now?
Yep.
We'll back down to 14.
It's like I told you.
Whatever. Okay. The mean age of the 14 students. So we're backing down to 14. The mean age for the students in the class is, what was the number? 18.4550. Is that true?
Yeah, 4450.
4450? 4550.
4450.
4450.
Did you hear that?
4450. Okay, construct a 95% confidence interval. So, formula is this guy here. We need T
Which is 1.96.
times S over the square root of N. T is how much?
1.96 again.
If you look up 95%,
It's the same thing.
nope, we're on the T chart now.
Oh.
95% at how many degrees of freedom? 13. 13 degrees of freedom. 95%. 2.160 times. What was the standard deviation, by the way? 0.3553. All over the square root of 14. That tells me my error. Eli, help me help you.
Wakey, wakey. Write this down.
Were you sleeping in Mr. Ruth's class or not?
He was.
No.
Yes, he was.
Yes, you
Because I couldn't see
The
you because
first
I was
time.
sitting behind you.
The
but-
first time I was starting to go, but I never actually fell asleep. The second time, when he asked me,
Tell me when
about
you get
it,
this error, somebody.
I had my eyes open the second time.
No, we didn't.
Yes, I
I
did.
was sitting right back next to him. I got.
She can hear you
0.205.
snoring.
I got 0.205, but I didn't.
0.205 for an error?
Yeah.
Yeah?
We're like
Okay.
halfway close.
What are we adding and subtracting from?
I can't believe
18
you
point
had
whatever.
like
18.4450 minus 0.205 and 18.4450 plus 0.205.
18.65 is the high one.
18.24 is the low one.
I'm
Perfect.
glad we
What'd
did.
you say,
I'm glad we
Eli?
did different ones.
Nice.
Yeah.
There you
No, he
go.
was like this.
18.24 and 18.65. We are.
I also think that he didn't mean
Write
to.
this
I think
down.
he just
Why?
We are
95% confident.
95% confident. Woo. That if we survey all BH seniors,
Why is this so small?
Yeah, why'd you give it to
Sorry.
me?
what?
18.
18.24%.
Their what?
Their average.
Their average age will be between 18.24 and 18.65. Now, that may not be true because if we survey all Blue Hill seniors, we've got Daniel in there, and Daniel's going to pull the average way down, right? But maybe not enough to be below 18.24, I don't know. But I'm going to guess you guys are going to be closer to this number than this number if we survey all of you, right? Okay, Daniel's going to pull that average down
What is
because he's young.
He's like 17.
He's like just turned 17 not too long ago.
Like December though, right?
Yeah,
Maybe like 17 and a half or something.
he's really young. Okay, all right, last one, standard deviation. Are we ready? For the, let's go with 14 students again. In this class, the standard deviation for their ages was 0.3553. Construct a 95% confidence interval. All right, which chart are we on?
Okay, we're doing
T.
We are on the chi chart. 95% at how many degrees of freedom?
should be Chi chart.
14
chart
or 16.
13. You were the one that called it chi chart.
many?
Josie?
Oh.
You were the one that said chi in the first place. That's why I call it the chi.
Okay, do you want them both?
Chi though.
Do you want them both?
It is chi. Okay, 95% at 13 degrees of freedom. What is the left one?
5.009.
Alright, how many?
Okay. Right is
24.736.
perfect. Is that right?
Right, yeah.
Okay. I figured.
No.
It's
Okay.
fun to say chi, but it should technically.
All right, now this is the only one that we do not calculate error for, right?
Yay.
We do the two thingy things, okay?
Ew.
So this first one is the square root of n minus 1 times s squared over the chi squared right, because the right goes on the left, right? N minus 1 s squared over the chi squared left one. Okay, what is n minus 1?
13.
13.3553 squared. 13 times 0.3553 squared. The chi squared right number is on the left and the left is on the right.
Word. Woo.
So our standard deviation should live between something and something.
First number 2.5.
Whoa, what?
Or 0.258.
0.258, okay. And point
We choose a different like decimal every time.
I know we do.
0.572.
0.572. Oh, whatever. We are
95%.
0.572.
95% confident that if we
Survey.
all BH seniors, the
ST
standard deviation
is equal
for what?
Age.
For their ages.
for ages
Their age
is between
will be between
0.258
0.258
and 0.572.
and 0.572. Boom.
Done.
How about that?
One page left. We could just do it now. How much time do we have?
No, we get out in like 3 minutes.
No.
Holy cow.
Okay, one more page. We got it in us. One more page. And then we never have to do
Look
math
at this
again.
cute little giraffe on the
Yay! Tomorrow we will be done with stats tier.
What pages do we need to
Are we gonna tier
No.
No.
of joy?
Happy.
Yeah. Okay. All right.
I really just
Okay.
wanna, like, just